In this video, we're going to look at graphing the other four trig functions, that not being sine and cosine. We're going to start with the tangent function. Now, the sine and cosine function are almost identical other than where their points land. The tangent function is going to be slightly different than that. The tangent function has the same situations where we're going to go ahead and say that there's an a value. Now, I'm not going to call the a value the amplitude because amplitude by definition doesn't exist in a tangent function. The amplitude, by a more appropriate definition, is the furthest value from the x-axis that the graph lands. In a sine or cosine function, this is normally 1 or negative 1. And again, the value in here multiplies and shifts that, expands that and stretches it by a certain amount. Well, the tangent function, it doesn't have a value that's furthest from the x-axis. The tangent function, the way that it behaves, it can reach infinity and negative infinity in terms of the y-axis. So again, when we refer to a for the tangent function, don't think we're referring to the amplitude, but call it the anchor point value in terms of the y-axis. So the amplitude is going to be again still your absolute value of a, but again, by definition, there is no amplitude for a tangent function. The period is also different. The period for the sine and cosine function was 2 pi divided by b, but for the tangent function, it's pi divided by the absolute value of b. That's because the tangent function starts repeating itself after a shorter span of distance. So in this case, pi over b is a more appropriate period for the generic tangent function, such that the generic tangent function is y equals pi. Is p equals pi. And then you still have your phase shift. Your phase shift doesn't change at all. It's still going to be negative c divided by b. Assuming that you have a plus sign here, your phase shift should be negative. If you have a negative sign here, then your phase shift should be positive. So let's go ahead and talk about the tangent function and how it looks like. So y equals the basic tangent of x is supposed to be, again, in this case, the amplitude is 1. Your period is pi instead of pi over b because there's no b value, and you don't have a phase shift. Again, if there isn't a phase shift, you should state either 0 or none. If the question asks for phase shift and you leave it blank, the assumption is that you don't know what the phase shift is, and therefore you're going to lose points for that. So for the tangent function, let's go ahead and set up those 5 anchor points. Now, what's nice about the tangent function, just like that of sine and cosine, is that there are still 5 anchor points that are important. They start at the end point of the period, so pi. Cut that in half, you get pi over 2. Cut that in half, you get pi over 4. You're still going to multiply that by 3 to get 3 pi over 4. And then you're going to have your 0 marker. Okay, don't forget that there's still 5 anchor points. Now, the drastic difference between tangent and sine and cosine is that tangent has a different way that it behaves. So if we talk about tangent, tangent is the same thing as sine over cosine. If we look at the unit circle for sine over cosine, the tangent of 0 is actually going to be 0 over 1. So that first location is actually going to be 0. Then if I plug in pi over 4, that's going to be radical 2 over 2 divided by radical 2 over 2, and therefore going to be a positive 1. So I'm going to go ahead and plot that up here to the best of my ability. Now I'm going to do this in pencil because of the way that this graph works. It's always difficult to pinpoint the way that this graph should behave. So I'm going to plot it there. I'm going to put my dash here as 1. Again, I might go back over this in pen, but what's important is how I'm going to sketch this. Now at pi over 2, when we get there and we go back to the unit circle, we ask ourselves, what is the sine divided by the cosine? Well, the sine value of pi over 2 is 1, but the cosine of pi over 2 is 0. And when I have anything divided by 0 in a rational form of a function, you have to remember, say, back in 1 over x, that kind of function is going to have an asymptote at the x value of 0. So the same exact concept happens when we talk about a tangent function at pi over 2. Its middle location is actually an asymptote. So it goes 0, high, and it's not really a high point, but it's the high point that we have marked. Then we go to the asymptote. Then when I go to 3 pi over 4, we're going to be at a negative 1. Now I'm going to try and angle this so that it's relatively close. So there's your negative 1 point. And then it's back to 0. So now if I'm sketching this appropriately, the values will start at 0, they will increase to 1, and then they will continue to increase approaching that asymptote. So that's what that half of the graph should look like, and from here the same thing should be happening, except for it's coming down from the asymptote, I should say up from the negative side of the asymptote, and it should hit that point there. So it should come down like this, more or less, passing through that point and touching that location, such that it continues on down forever like that. Now this is not a good form of the tangent function. Okay? What's important to note is that the tangent function has a cyclical period such that its generic period has a value of pi, which means that after pi it starts repeating itself. But if we don't want a broken function very much like this, we're going to have to be very specific about what section of the tangent function we want to define. We don't want to go from 0 to pi. What we really want to do is we want a period that focuses on negative pi over 2. And actually, I shouldn't have equal signs in there because that pi over 2 value isn't included to pi over 2. So this function is acceptable. This is an acceptable graph for the tangent function. But if it says graph one continuous period of the tangent function, what we really should graph is a graph that's cut in half where we end at pi over 2 and we start at negative pi over 2. Because again, this function is cyclical, I should feel comfortable knowing what it's supposed to do in these two sections because I know what it does in these two sections. So again, all the points are more or less the same. There's my 0, there's my so-called 1, there's an asymptote here, there's an asymptote here because that's a repeat of this location all over again. My negative pi over 4 is the low point, so that's my negative location, so somewhere about here, and then this should curve down into this location, nice smooth curve, and then cut back out, approaching that asymptote in that direction. And that is what one smooth curve, one complete continuous curve of the tangent function is supposed to look like. Again, this is an acceptable graph if it asks what is one period of the tangent function, but if it specifically adds the continuous part, we have to deal with this. So again, the rules don't change other than the fact that it's pi divided by b instead of 2 pi divided by b. So if we look at one more version of this graph, let's just say y equals, let's put a 3 tangent of 2x. So very much similar to one of the cosine functions we did in the past, but now we're just looking at tangent. The amplitude, again, which the tangent function doesn't officially have, that's why I'm labeling it as an A and not AMP, but the sine and cosine have amplitudes. The tangent and actually all other trig functions do not have an actual amplitude value. But that value is still important. It's the absolute value of that 3, and therefore it is 3. My period, remember, is pi divided by, in this case, my b value, which is 2. And then my phase shift, I don't have one for this particular graph, so we're not going to identify one. And then we're going to go ahead and graph one period of this tangent function. Again, emphasizing the one period, not necessarily continuous one period. So at least one period. I'm going to end at pi over 2. Cut that in half, that's going to give me pi over 4. I'm going to cut that in half, that's going to give me pi over 8. I'm going to multiply that by 3, giving me 3 pi over 8. And then I'm going to go ahead and make sure I identify my 0. Now, the tangent function is 0, the so-called high point, asymptote, the so-called low point, and then back to 0. Now the reason why I didn't plot those points is because I like to make a nice smooth curve out of this, and the best way to make a nice smooth curve is to avoid plotting those points and simply draw the smooth curve approaching that asymptote on both sides. And normally your hand does a pretty good job, as long as these things are equidistant from each other, of identifying this point being nearly equal distance on the y-axis. So up here I'm going to have a value of 3, and down here I'm going to have a value of negative 3, and notice 1, 2, 3, 4, 5 important anchor points are still there. So that's how you graph the tangent function, again with 5 anchor points. Your period is the only formula that actually changes for tangent, but the curve of the graph is also drastically different. Just making sure that you remember it's 0 high, asymptote, low, 0. This is different than the sine and the cosine functions because it doesn't have any asymptotes in that form. That right there is how you graph a tangent function with, again, either amplitude modifications, period modifications, and the phase shift modifications don't change from how you handle this. You know what these 5 anchor points are. If I had a phase shift, I'd shift it again left or right based on that phase shift, and the delta x being pi over 8.